Good day once again. I want to welcome you all to Math Invisible Tutor, in which our work is to be making mathematics easier for everyone. Yeah, because the world is all about math. So, what are we going to be dealing with in this video? Is the topic which is indicial equations. So, and what do you understand by indicial equations? So, as has been written, indicial equations, also known as exponential equations, which are equations that the unknown is at what? Is at index. I don't know if you have been acquainted with quadratic equation or polynomial or cubic equation. You will see that the unknown is at what? Is at the base, not the power or the index or the exponential. So here we'll be focusing on how to solve equations that involve in the indicial equations, such that the power is at what? Is the unknown is at what? Is at index. So in this video I solved up to like 20 different questions, and with these 20 different questions, I believe if you pay attention and watch this video, I believe you should be able to tackle any indicial equations given in the future or in any class, because it might be of help even for the university level or university student. So the first question is a little bit simple. You are asked to find x, given that you can see that the unknown is at what? As the index. Given that what? 5 raised to power 2s equals what? Equals 1 over 625. And solution says that what? 5 raised to power 2s equals 1 over 625 will be equals to 5 raised to power 2s, which is equal to 1 over 5 raised to power 4. That's 625 changed to 5 raised to power 4 because what? Because we change it to index form. And the index form of 624 is 5 raised to power 4. That is, we are multiplying 5 in 4 different places. That is 5 times 5 times 5 times 5. So the next line is that what? We change it to negative index. We are applying negative index rule, shows that whenever you have an index at the denominator, shows that the numerator part is 1, you can change it to negative index. That is 1 over 5 raised to power 4 can also be written as what? 5 raised to power minus 4, all the same. So that's why you see that the expression 5 raised to power 2s equals 1 over 5 raised to power 4 equals what? 5 raised to power 2s equals 5 raised to power 4, power minus 4 rather. So note is being given here. Once the base of the left hand side equals right hand side, then you can equate their index together. So which means that 5 raised to power 2s, which actually equals to 5 raised to power minus 4, can be written as what? 2x equals minus 4. And the final answer is what? S equals minus 2. That is what the note is trying to say, that once the base of the left hand side equals the right hand side, then you can equate their index together. So just let me zoom out and go through the first example solution. So go to example 2. So this is the solution. Before I explain, you can check through. You can do it by yourself first and compare the solution with each other. So example 2 says that given that 1 over 3 multiply 9 raised to power 2s equals 27 raised to power x, we are asked to find the x. You can see that we have x at the left hand side and also at the right hand side. So how can you solve this? It's very simple, and the solution is that 1 over 3 multiplied by 9 raised to power 2s equals 27s can be written as the one at the front of the implication sign, that arrow there, which is what I told you. Whenever you see something that involves 1 over 3, you can apply negative index rules. That is, you can change it back to 3 minus 3 raised to power minus 1, or anything that is serving as the index of the base at the denominator. I hope you get the grammar that I just given now. For instance, maybe you have 1 all over 2 raised to power 2. The index of the denominator base is what is 2. So, and that kind of expression is actually fraction, but applying negative index will definitely be what? 1 over 2 raised to power 2 will definitely be what? Will be equals to 2 raised to power minus 2. So that is what I'm trying to say there. So we apply the same principle here. So don't be surprised that 1 over 3 eventually change to 3 raised to power minus 1. It's negative index rule. So I've explained it in the first video regarding indices. So now we move further. You see that the expression has now been written as what? 3 raised to power minus 1 multiplied by 3 raised to power 4x. So, and in the first line of that solution, you can see that we change them to what? Inside the parentheses, that change to 3 raised to power 2. Yeah, that is 1 over 3 multiplied by 9 raised to power 2 s equals 27 raised to power x, as eventually change to what? 3 raised to power minus 1 multiplied by, inside the parentheses we have 3 raised to power 2, which is also the same thing as 9. Everything all raised to power what? 2x. And the one at the right hand side, which is 27 raised to power x, has eventually changed to what? 3 raised to power 3 inside parentheses, everything raised to power x. So you will see that in the next line, this has been simplified further, that what? 3 raised to power minus 1 multiplied by 3 raised to power 4 is equals what? Equals 3 raised to power 3s. That is product law. Actually, we've applied product law. If you don't know this, just go to the previous video that involved indices. You will see it there, and try to watch the video for you to have better understanding of what we are dealing with in this video. So you will see that the next line is now what? The expression has now changed to what? 3 raised to power minus 1 plus 4x equals 3 raised to power 3s. That is what? That is multiplication law, because between the one at the upper line at the top of that expression, you will see that 3 raised to power minus 1 multiplied by 3 raised to power 4x equals that multiplication between 3 raised to power minus 1 multiplied by 3 raised to power 4x. We eventually, that was what made the below expression to be what? To be 3 all raised to power minus 1 plus 4x equals what? 3 raised to power 3x. So applying the same principle we apply in the first example, once the base of the left hand side equals to the right hand side, then we can equate their indices together. So that is why we're having what? Minus 1 plus 4x equals what? 3s. Then you collect the like times, normal mathematics. So that is why we have 4x minus 3s equals 1, and which eventually equals to x equals 1. So that is the answer for what? For that example 2. Let me zoom out again. I've already given you the preview of it actually. So, but you can still check. So that is the solution for example 2. Then we move to example 3. So if you are asked to find x again, because I told you that this topic is will be helping us in solving unknowns, just that the unknown is at the what? Is at the index. That is what is called indicial equations, or you can call it exponential equation. Indicial what? Indicial equation, or what? Exponential equation. So that is what we'll be dealing with here actually. Everything, the unknown will be finding will be in the index. So this another example given here, I have to find x, given that 3 inside parentheses 2 raised to power x minus 3 equal 384. And how can you solve this? I've simplified it. I've broken some necessary thing down there that you don't need to just think, how is this being gotten? No. So everything is well explanatory, it's well explained. So recall that 2 raised to power x minus 3 actually equals to what? You can have it in two expressions. You see that what? 2 raised to power x all over 2 raised to power 3, or what? 2 raised to power x multiplied by 2 raised to power minus 3. Thus, we have in the next line to be what? So changing the expression here, that's why you are saying that so you can, so that is why we're having 3 inside the parentheses, in which we have inside the parentheses we have 3 multiplying what is inside the parentheses, that is 2 raised to power s multiplied by 2 raised to power minus 3 is equal to 384. So knowing this, so once you know that 2 raised to power x minus 3 can be written as 2 raised to power s multiplied by 2 raised to power minus 3, then we can divide both sides by what? By 3. That is why you are saying that here, you can see, I'm zooming for you to have better view of what we are dealing with. So you can see that 2x multiplied by 2 raised to power 3, I mean 2 raised to power x multiplied by 2 raised to power minus 3 equals for 384 divided by 3, which is telling you that that 3 are the that 3 multiplying to 2 raised to power x multiplied by 2 raised to power minus 3 has been used to divide both sides. That is why you have seen it being eliminated at the left hand side, and you actually saw it at the what? At the right hand side. So, and what will be the expression? The expression, when you divide 384 by 3, you have 128. You can press your calculator and confirm that. So, and recall that I told you whenever you have negative index, you can change it back to fraction, and the format is what? That will be what? That will be let me just show it here. So don't be shocked why we have multiplied by 1 over 3, 1 over 8 rather. So recall that 2 raised to power s multiplied by 2 raised to power minus 3, which is equal to what? 128 actually, or let's say which is equal to 384 divided by 3, is what can be written as that 2 raised to power minus 3 can be written as this, which is what? 1 over what? 2 raised to power 3. Yeah, the same thing. So which is eventually equals to 128. So now if you change it back to normal form, 2 raised to power 3 is actually 8. That's why we're having in the next implication line that what? 2 raised to power s multiplied by 1 over 8 equals what? 1 over 20 equals 128. So looking into this, so we have next line that if you cross multiply, then we have for 2 raised to power s equals what? 128 multiplied by 8. So which implies that 2 raised to power s, recall, you can see that at the right hand side we change everything back to indices. Yeah, that's why you have 2 raised to power 3, that is 8, and then multiplied by 2 raised to power 7, that is 120. You can press your calculator to confirm this. You will see that it's actually true. So the next implication line states that what? 2 raised to power s is now what? You can see that the power of the right hand side, that is 2 raised to power 3 multiplied by 2 raised to power 7, have been changed to addition. Why? Because we are applying multiplication law. So 2 raised to power s is now what? 2 raised to power 3 plus 7. So which implies that 2 raised to power s equals what? 2 raised to power 10. So now I've said it in the first two previous example that whenever the left hand side base is equal to the right hand side base of an index, then you can equate their indices. You can equate their indices together. I hope you get what I'm saying now. So that was why you see that x index at the right hand side, at the left hand side is equal to what? 10 index at the what? At the right hand side. That is why we have what? X equals to 10. And if you put that value inside the actual example given, if you check, you see that the left hand side is actually, if you solve it very well, you see that the left hand side is actually equal to the what? Right hand side. So let me zoom out again. So that is example 3. So we go back to example 4. So you are seeing as you are moving into different examples, it's getting a little bit more complex, but don't worry. Just follow the right steps and you are going to get the correct answer. So you have to find the value of s given that 16 raised to power 3s equals what? 1 over 4 inside parentheses 32 all raised to power x minus 1 close parentheses. So the solution is now, you can see, we've changed the 16 raised to power 3s to what now? We change it to index. That is 2 raised to 16 raised to power 3x is now what? Inside the parentheses 2 raised to power 4 all raised to power 3x. And that 1 over 4 is negative index, which has been written as 4 raised to power minus 1, multiplying everything inside the parentheses. That is 32 all raised to power x minus 1, which can be eventually written as what? 2 raised to power 5 everything raised to power x minus 1. So for us to have same base, you can still change that 4 into what? That's why you will see here that what? So the next thing we apply here is called what? It's called we apply so different laws. We apply product law because the expression 2 raised to power 4 inside the parentheses multiplied by the index of 3x has now changed to what? 2 raised to power 12x, because it's product law. By multiplying what is the index inside the parentheses multiplied by the index outside the parentheses. So that's why we're having what? That's why we're having 2 raised to power 12x, which is eventually equals to what? Yeah, if you observe also that 4 raised to power minus 1 has now changed to what? Has now changed to 2 raised to power 2 inside everything inside parentheses all raised to power minus 1 multiplied by that 2 raised to power 5 still retain itself multiplied by what? 2 raised to power 5 multiplied by parentheses x minus 1. So following this, the left hand side still retains itself, which is 2 raised to power 12x. Now if you apply product law, you will see that that's 2 raised to power 2 at the top inside parentheses all raised to power minus 1 has changed to 2 raised to power minus 2 multiplied by what? 2 raised to. Now you will see that we've multiplied 5 with everything inside the parentheses. That was why we have multiplied by 2 raised to power 5x minus 5. So having this, then you can do what? You can now apply multiplication law. So let's just forget about the left hand side of the equality and focus on the right hand side. So focusing, because left hand side still retains itself, which is still the same, but where the multiplication sign exists is at what? Is at the right hand side. So that is why we have 2 raised to power minus 2 plus 5x minus 5. That is multiplication actually. So simplifying it or solving the expression, we have at the right hand side now, just focus on the right hand side here. We have what? We have 2 raised to power 5x minus 7. So actually you can solve the next line in 2 ways. You can follow the previous method I've been applying by what? Once they have the same base, you don't need to stress yourself this, but you can still learn from this. You can just equate this 2 raised to power 12x, which is equal to what? 2 raised to power 5x minus 7. Once they have the same base, you can equate the left hand side index with the right hand side index. That is 12x equals 5x minus 7. So writing that and collecting the like times, that is 12x minus 5x equals minus 7. So and 12x minus 5x is what? Is 7x. So if you divide both sides by 7, you have what? X equal to minus 1, and which is this. So now let me explain this expression from the one I actually written. That's what I love about mathematics. Once you just understand the basic, sometimes we don't need to follow the same, actually it's the same path, but not that will not be that identical. You get what I'm saying now? Not be the same actually, but it will look little bit exact. So now from here, I'm just trying to make life easier for myself from my own, and that one also you make life easier for just apply the the step directly by equating the index of the left hand side with the index of the right hand side, and you get your answer. Once they have the same base, the base of the left hand side is the same with the base of the right hand side. So here I try to simplify for that by saying that what 12, the expression 2 raised to power 12x equals 2 raised to power 5x minus 7. You can simplify it for that by saying that 2 raised to power 12x equals what? I just reversed the multiplication law. Equals what? It's still multiplication law. Equals what? 2 raised to power 5x multiplied by 2 raised to power minus 7. The expression 2 raised to power 5x minus 7 is also the same thing as 2 raised to power 5x multiplied by 2 raised to power minus 7. So after that, I try to divide both sides by what? By 2 raised to power 5x. That was why you were saying that 2 raised to power 12x divided by 2 raised to power 5x is equal to what now? 2 raised to power minus 7. So now after that, applying division law here, you can see from here, that is 2 raised to power 12x divided by 2 raised to power 5x. So once you see division in between indices, so definitely you apply what? Division law. So that was why the expression from here 2 raised to power 12x divided by 2 raised to power 5x equals 2 raised to power minus 7 has changed to what? 2 raised to power 12x minus 5x equals 2 raised to power minus 7. And from what I've said earlier, applying the principle or the step, we state that what? Once they are having the same base, you can see that now 2 raised to power 7x equals 2 raised to power minus 7. They are having the same base, which is 2. So definitely you can equate their indices together. So that's why 7x equals to minus 7. So I divide both sides by 7, you have what? X is equal to minus 1. So you get now. So all the same. So that is the expression for question 4. That is the solution for it. So let's move to question 5. So the solution, the question says solve the equation shows that what? 3 raised to power 1 minus 3 raised to power 1 minus x multiplied by 4 raised to power 2x minus 1 multiplied by 12 raised to power x equals 3. You say, yeah, why is this 12 occurring now? Don't need to be panic. The mathematician, all the examiners, all the people that set question want to play with our intelligence, how we can think. So you just need to make life easier for yourself actually. And this is the solution for this expression. Don't mind that it's a little bit cumbersome, but you can just check this zoom out solution first before I start explaining. And see, this is the solution here. It's well explanatory. Don't need to be panic. So the solution is now that what? Let me follow from the solution line. So 3 raised to power 1 minus 7 multiplied by 4 raised to power 2x minus 1 multiplied by 12 raised to power x equals 3. So the implication lines follows that what? The implication symbols follow that what? Now I first do what? I first converted it to indices in most the expression that need to be converted to indices. I did that, and so that was why we have in the front of that implication sign that what? 3 raised to 1 minus x multiplied by, you will see that that 4 has changed to 2 raised to power 2. Like I said earlier, everything all raised to power 2x minus 1 multiplied by what? Multiplied by 3 multiplied by 4. Inside parentheses, everything all raised to power. You see that 12 has now changed to what? 3 multiplied by 4, which is actually true. You're supposed to ask that why didn't I use 2 multiplied by 6? You can still use that actually, and we still derive at the same answer, because 2 multiplied by 6 can still be written as what? 2 multiplied by 3 again, and that is what? 2 multiplied by 2 multiplied by 2 multiplied by 3. So all the same, just okay. So everything equals to 3. So the next expression here is that what? At the front of that implication sign is that what? That is so here you can see from here, I just want you to focus on this, what is at the front of that implication sign here. So that is 3 raised to power 1 minus x multiplied by inside parentheses 2 raised to power 2, everything raised to power 2x minus 1. So you will see that I've applied product law in the expression that state that 3 multiplied by 2 raised to power 2. You understand how we got 2 raised to power, that is 4, changing it to index, that is 2 raised to power 2. So you see that in this line I've splitted them using product law. So that is why 3 raised to power x has been removed from that. I've been removed from that parenthesis. Now it's now multiplying what? Inside the parenthesis 2 raised to power 2 all raised to power x equals 3. So here in the next line we have 3 raised to power 1 minus x. You see that I'm not touching that now. Multiply by. So applying product law, that's why we have 2 all raised to power 2 inside parenthesis 2x minus 1, all the same. Now multiply by 2, 3 raised to power x multiplied by 2 raised to power 2x equals 3. So in the next implication line, following the next line, so we have 3 raised to power 1 minus x multiplied by 2 raised to power 4x minus 2 multiplied by 3x multiplied by 2 raised to power 2x equals 3. So connecting the like base at the left hand side. So if you are collecting the like base at the left, you can see the expression of the left hand side there. So if you're collecting the like base, that is the same base. So you can see in the front of that implication sign in the same line, you can see that, look at the left hand side expression. We have 3 raised to power 1 minus x multiplied by 2 raised to power 4x minus 2. After applying product law, that was why we derive at that expression, multiplied by 3 raised to power x multiplied by 2 raised to power 2x equals 3. And we see that we've applied what? We've connected the like base, and that is an also what? Apply multiplication law. So that is why the 3 that is having same base, we've added the what? We've added their indices together. So that is why we're having what? At the front of that implication line, the same line, we have 3 raised to power 1 minus x plus x multiplied by the same thing to the base of 2. We've added their indices together. That is why we have 4x minus 2 plus 2x equals 3. So that is why we're having in the next expression that what? So from here you will see that from the first implication sign we have 3 raised to power 1, because 1 minus x plus x is actually, the remaining will be 1. So I recall anything raised to power 1 is still that same value. So multiply by what? Multiply by 2 raised to power 6x minus 2. If you find the expression 4x minus 2x plus 2x is going to give you 6x minus 2 actually. So that's why we're having that. Everything equals to 3. So dividing both sides by 3 now, we now have what? We now have 2 raised to power 6x minus 2 equals 3 divided by 3, which is actually 1. That's why we have 2 raised to power 6x minus 2 equals 1. So applying the same method, the same principle, and recall that 1 equals 2 raised to power 0. Anything raised to power 0, any value or any number raised to power 0 is what? Is 1. So thus we can now re-express the expression which says that 2 raised to power 6x minus 2 equals 1 as what? 2 raised to power 6x minus 2 equals 2 raised to power 0. We are using 2 raised to power, it can be anything. One, if it is, let's say the left hand side base is 3 now. Instead of using 2 raised to, you can use 3 raised to power 0. Sure you get now. So in order for us to equate the left hand side indices or indents together with the right hand side indents, they must have what? It's just the basic. They must have constant or same base. Sure you get now. So that was why I changed that one equals to be what? 2 raised to power 0. So 6x minus 2 equals was 0. So so x is equal to what? 2 all over 6, and x is equal to what? 1 over 3. So that is the solution for that. Let me still zoom out again. So thank you. So I move to question 6. At least I will try to, okay. So example 6 says that find x from the given equation. You can see that this one is a little bit complex compared to the 5 previous examples I've explained and I've solved. So the equation given is that 3 raised to power 2x plus 1 minus 12 inside parentheses 3 raised to power x plus 9 equals 0. So how can you solve this? It's just simple. So let me just go to the implication sign directly, because the left hand side is just a repetition of the question given. So from the right hand side here, or let's say from the implication side here, sign here, you can see that as apply multiplication rules allowed to that expression, we state that 3 raised to power 2x plus 1 equals now is now equals to what? It's now the same thing as 3 raised to power 2x multiplied by 3. So minus 12 inside parentheses 3x plus 9 equals 0. So from here, you can see that the expression has now changed to what? 3 inside parentheses 3 raised to power 2x minus 12 inside parentheses 3 raised to power x plus 9 equals 0. So can still be expressed as what? 3 inside parentheses 3x all raised to power 2 minus 12 inside parentheses 3x plus 9 equals 0. So we now say let y equals 3 raised to power x, just by saying that this expression here cannot be changed to what? Cannot be written as 3y squared minus 12y plus 9 0. How? Because you said let y equals 3 raised to power x. So anywhere you see 3 raised to power x, you just put your y. And recall that the first expression is 3 inside parentheses 3 raised to power x, everything raised to power 2. So that's why you have 3y squared minus 12y plus 9 equals 0. So once the value given, that is 3y squared minus 12y plus 9, 3 can divide through. So you just divide this equation by 3. So that was why we're having the expression here after, you see. So we're having as y squared minus 4y plus 3 equals 0. So we can solve this by what? By using factorization method or quadratic formula or completing the square. Anyone you feel like using, because this has led us to what? Quadratic equation. So and me, I'm using factorization method. That's why I wrote here that y the product of the root. So you can see that the sum of the root is what? Minus 4y here from here, and the product of the root is what? Y squared multiplied by plus 3x. So you can see here that is why we're having 3y squared. So then how can you simplify? So from my own intuition or from my own thinking, I deduce, or I believe that minus y multiplied by minus 3y will definitely give you 3y squared. And for you to pick any number or any factor, it must obey the sum of the root and the what? The product of the root. So if you see, finding the product of the root, find the expression that will obey the product of the root and the sum of the root using minus 1 and minus 3y. Actually, it obeys what? The product of the root. And also if you add them together, which is sum of the root, minus 1 minus 3y, definitely what? Obey what? The sum of the root too. That is why I can actually pick minus y and minus 3y as my factor. Sure you get now? Let me just zoom out for you to have a better view of this. So yeah, so let me zoom in again. So that means minus y can be expressed as what? Minus 3y minus y. So you can see the equation, the quadratic equation y squared minus 4y plus 3 equals 0 has now been expressed as what? Y squared minus 3y minus y plus 3 equals 0. Then you factorize. So factorizing, you can see you can factorize y from y squared minus 3y, which is what? That is y inside parentheses y minus 3 minus y inside parentheses y minus 3 equals 0. So what is constant there is 1 minus 3. Then you bring it, you multiply them together. That is why we have 1 minus 1 inside parentheses and 1 minus 3 inside parentheses, all multiplying each other equals 0. So your y is either what? Your 1 minus y equals 0 or your 1 minus 3 equals 0. So eventually y is equal to 1 or y is equal to what? 3, which means y is either 1 or 3. So then that is one part. We haven't gotten the real answer. So then you say when y equals 1, thus recall that you said let y be equals to what? From this expression, let y be equals to 3 raised to power s. So once you gotten the value for your y now, then you can now relate them together. So If y, or when y equals 1, thus 1 equals 3x. Recall, I've said it earlier that anything 1 can be expressed in any format, that is format. So that's why you see y is equal to what? 3 raised to 1 is equal to 3 raised to power 0. All the same, 3 raised to power 0 is 1. So we use 3 raised to power 0 because we want to eliminate the base, or you want to equate the index of the left hand side with the what? With the right hand side. So that is why you must use constant base. You must have same base for the left hand side and the right hand side for you to equate. So 3 raised to power 0 equals 3 raised to power x, which implies that x is equal to what? 0. So, and also when y is equal to 3, then that is 0 raised to power actually, which means x is equal to 1. So that means your final answer is either what? Y is either 0 or 1, which means for any value of the two, your x will be definitely be true. The expression will be definitely be true. If x is equal to 0, the expression given here, the question given will be true. Just put your 0 here, you will definitely see that everything will be equal to 0. And also if x is equal to 1, just put 1 here, you see that everything will definitely be what? 0. Thank you. So this expression 2, so we're having 2 over 3 all raised to power m, and multiplied by inside parentheses 3 raised to power 4, 3 divided by 4 all raised to power n. Everything is equal to 256 divided by 729. So you have to find the value of mn. So how can you find this? So this is the solution here. Just apply the product law. Consider that the expression for 2 divided by 3 all raised to power m has been written as what? 2m multiplied by 3 raised to power minus m. That is what? That is division law. And multiplied by same thing has been done with this 3 divided by 4 raised to power n. So that is why you are seeing the expression as 3 raised to power n multiplied by 4 raised to power minus everything equals to 2 raised to power 8 and 3 raised to power 8. That is the indices format for 256 divided by 729. So we simplify further. So you can see that actually not the same base, but if you simplify further, we see 4 will actually be of the same format with what? With 2. So that is why I try to collect the expression that seem to have same base. So that's why we have 2 raised to power multiplied by 4 raised to power minus n multiplied by 3 raised to power n multiplied by 3 raised to power minus m. Everything equals to this. So you see here in the right hand side, I've applied what? I've applied division law. Also I've applied division law actually. Division expression actually. I haven't applied division law but division expression, because 2 raised to power 8 divided by 3 raised to power 8. If you say 2 raised to power 8 multiplied by 1 over 3 raised to power 8, you see that is negative in there. That's why you have 2 raised to power multiplied by 3 raised to power minus 8. Sure you get now? Yeah. So you can see that here we've eventually changed 4 raised to power minus n into what? Into 2 raised to power 2 all raised to power minus n. So then after next line, we can then what? You see that here we've applied what? We've applied multiplication law. That is why you see the expression of 2m multiplied by 2 raised to power 2 raised to power n multiplied by 2 raised to power minus n. Actually, we've already applied product multiplication law to this one. That is why 3 raised to power n multiplied by 2 raised to power minus m has now changed to 2 raised to power n minus m. The same thing has been done to the base of 2 with different base. That is why we are having the expression 2 raised to power n multiplied by 2 raised to power minus 2n to be what? 2 raised to power m minus 2n multiplied by 2 raised to power n minus m, which everything actually equals what? 2 raised to power 8 multiplied by 3 raised to power minus 8. So like we've been doing, comparing the index with respective base of both RHS, that is right hand side and left hand side. Thus we have what? We have 2m minus 2n to be equals to 2 raised to power 8 and 3nm equals 3 raised to power minus 8. So that's why we have equation 1, m minus 2n equals 8, because they're having the same base. That's why we take that one as equation 1 for the one that has the same base of 2, and for the one that has the same base of 3, we have the expression to be n minus m equals minus 8. That is equation 2. So you know how to solve your simultaneous equation. So thus let m equals from equation 2. Let n be equals to what? M minus 8. You should understand that. So you can now substitute for the value of n inside equation 1. So that's why you see the expression of m minus 2 n equals a to be now be what? M minus 2 inside parentheses m minus 8 equals 8. So if you simplify for that, we have m minus 2n plus 16 equals 8. So which m minus 2n will definitely be minus m, which is equal to minus 8. That is 8 minus 16. That is minus 8. So which eventually m is equal to 8. So you can substitute m equals to 8 back to the expression that states that let m equals m minus 8. And recall m is 8. So 8 minus 8 is equal to 0, which means our n is equal to 0 and our m is equal to what? 8. So that is the solution for that question given. N is equal to 0 and m is equal to what? 8. So let me zoom out again. So the initial equation is not that hard if you follow the right steps. So like what he did in the in the example 7, when we get to the simultaneous equation from, I just apply the same principle here. So I won't explain this, so just follow and see. So same thing we do to question 9. So don't worry, I don't need to explain everything because the note is well explanatory. Just follow the steps, follow the line. So I've solved something like this. Let me check. I think that is yeah, you can see it's little bit related. That one is, that says question 10 is even simpler compared to question 6. So you can check question 6 if you are a little bit confused. So just compare. So question 10, you ask to evaluate 2 raised to power 2x minus 6 inside parentheses 2 raised to power x plus 8 equals 0. So you can see that. So that is the step. Yeah, let's be in the example 6, we say let y equals to 3 raised to power x. Here I use p. You can use anything you want of your choice. You can use w, you can use z, you can use anything to represent each other. So you can see here factorization method I told you. You can use quadratic formula to fasten your work. Yeah, you can use quadratic formula because that one is just computing of the parameters. You can use completing the square, which is a little bit complicated, but it's your choice. So and the answer is what? X got to 1 and or 2. So this was the same thing. Question 11. That is the question, that is the solution, same process. This is question 12. Question 13. See, I've solved something related to this question 14. Can slide back and check and compare the steps, and it's actually same principle, same process. So your x is so the value for 3y minus 2x will be what? Will be 7, because our y is 1 and our x is minus 2. So you get, so that is 3 times 1 and minus 2 times minus 2 is plus 4. So that's why we have 7. So because you have to find the value of 3y minus 2. They can ask in any format. Just have the basic understanding, and I pray God should give you the wisdom to be able to tackle question, to interpret question, and to solve it. So that is the most important thing. So question 15, that is the solution. Just can check through. I'll zoom in. question 16, 17, sorry, this one should be 18. So question 19. So that's all about that. Let me just slide back.